So the first you should know what do you mean by series of function. So we already talked about the sequence of functions. The sum of the terms of the sequence of function, it's called the series of function. So the series of function summation n running from 1 to infinity fn of x defined on E is said to be converge uniformly on E if, so you probably know the definition of convergence series. The convergence series, when you want to say a sum series is convergent, you know that it is partial sum is sequence of partial sum is convergent. So it's the same definition we have here, that if the sequence of partial sum that is Sn of x, which is summation k running from 1 to n fkx defined on E is converge uniformly for on E. So if this sequence of partial sum, so what is this actually Sn? The S1 is the first term. S2 is the sum of two terms of that sequence. S3 is the sum of three terms. And so on. Sn is the sum of first n term. It is called a partial sum of the series. And if this sequence of partial sum is converged to a sum function uniformly, then we can say that the series is uniformly convergent. It is the same definition for pointwise conversion. If the sequence of partial sum is pointwise converged to some function, then it is pointwise conversion series. So every time if you want to check whether the given series is uniformly convergent or not, we have very interesting result on this sequence of series of functions. That theorem name, it's called the Weirstrass M-test. This is called Weirstrass M-test. And it is the test to check whether the given series is uniformly convergent or not. Let us write the statement for this. So if you have a sequence of functions which is bounded by mk, sequence of numbers mk, for every x is in E and k is in n, when mk is a sequence of constants. So mk is a sequence of constant. If the mn converges, then prove that the series n running from 1 to infinity, Fn converges absolutely, uniformly on E. Absolutely means the summation of mode Fk is uniformly convergent. This is absolutely, and so I can say that this series Fn is convergence absolutely uniformly converged on E. So ultimately, what is the sequence is bounded by some constant sequence or numbers. Then we can say that this series is uniformly convergent. So let us try to prove this statement. So let us take this epsilon greater than 0 to be given, and let Sn is the partial sum of this series, because I want to prove that the series is convergent, so we have to looking at its partial sum. So let us consider this is the partial sum of that. And it's given that the series Mn is convergent, series of sequence, given that the summation of Mn is convergent. Therefore, as per the definition, we can say that the partial sum of this, or I can say a partial sum is convergent, so partial sum is Cauchy. So we'll use the Cauchy's criteria to prove this is uniformly convergent. What is the Cauchy's criteria? We know that a sequence is convergent if and only if it is a Cauchy. That is known as a Cauchy's criteria. Or I can say a sequence is uniformly convergent if and only if sequence of function is a Cauchy sequence. So we'll use the Cauchy's criteria to prove this thing. So since this is convergent, so it's partial sum. Let's say that partial sum of this one is I can say let us say that is some notation An will be summation A running from 0 to m mk. So what is the An minus Am? If you have assumed that n is m is bigger, smaller, or I can just assume that n is bigger than m, and that is greater than or equal to n0. If I can assume, then what will be the value of An minus Am? Since this is convergent, this An has to be tends to its convergent sequence. This An is a convergent sequence. So, and it is a sequence of real number or a complex number. Yeah, it is a sequence of real number because its mode of this one is less than or equal to m2. So it is a sequence of real numbers. And real is complete space, so it is a Cauchy. So can talk about mode of An minus Am is less than epsilon. But what is this An minus Am if n and m is greater than or equal to n0? If n is bigger, then we know that this is equal to m1 plus m2 up to m plus, and then it is minus mn minus m1 to mm, because this is An, that is m1 m2 up to mn, minus Am is m1 m2 up to mn, and these values are cancelled out. So only left is m plus 1 to mn. So if I can write down all this calculation in short, therefore if it is this mn is conversion, I can say there exists n0 belongs to n. such that the summation of k running from m plus 1 to m mk is less than epsilon. Due to this, all calculation we have, where n is bigger than n is bigger than n0. So this is the situation we have. So now hence now, if your n is greater than or equal to n0 and n is bigger than m, if I pick these numbers, let us look at what is Sn and minus Smx. So this is summation k running from 0 to, or I can say, if I write 0 here, then I have written 1. So it is 1 to n skx minus 1 to m fkx. Since n is bigger, as the same argument we have given here, you can write down this is equal to summation k running from m plus 1 to n fkx. So by triangle inequality, we can say this is less than or equal to k running from m plus 1 to n mod of fkx. And as per the given argument, that is mod of fkx is less than or equal to mk for every k region. So in particular for this, we can write down this is less than or equal to summation k running from m plus 1 to n mk. And this is already less than epsilon for every n, m is greater than or equal to n, and for every x we have this. So therefore this is true when x is in E, and for every n, m greater than or equal to n0. We have this. Hence we can say that this sequence, by Cauchy's criteria, we can say that the sequence of Sn is uniformly convergent. Hence, by Cauchy's criteria, the sequence Sn of x is converged uniformly on E. Since this sequence of partial sum is uniformly convergent, the series k running from 1 to infinity fk of x is converged uniformly on E. And this completes the proof of this Weierstrass M-test. Okay, and we will solve certain examples on this Weierstrass M-test and to check whether the given series is uniformly convergent or not in the next lecture. If you have any question, you can ask.